is a welding robot from our lab. Welding robot. It is on the end shaft flange of the industrial robot. Install welding pliers or it can do automated welding. Currently, welding robots are the largest robot application field. About 45% of the total number of industrial robots. Common types of welding robots include arc welding robots, spot welding robots, and laser welding robots. What we're going to learn today is an arc welding robot. Let's take a look at what are the components of an arc welding robot. The arc welding robot is mainly composed of two systems. One is the robotic system by the robot body. The computer control cabinet is also composed of a controlled viewing angle device. The welding system is fed by a welding torch. The wire fitting mechanism above. It also consists of the following welding power supply. When these two systems are combined into one, it can be called an arc welding robot. The arc welding method we use today. It is a carbon dioxide gas shielded welding method. Gas shielded welding by carbon dioxide gas using the arc generated between the welding wire and the plate and welding wire. When welding, carbon dioxide gas is ejected from the nozzle as the wire fitting mechanism automatically completes the entire welding process. So how to achieve automated welding? Let's take a look next. We use the most commonly used in industry. It's called a 6-axis industrial robot. It has a total of 6 axle joints driven by 6 motors. When two motors are driven at the same time, the robot will move in space. It carries a welding tool with it as it moves. Welding gun movement plus some control of programs and instructions. Automatic welding can be realized. Then let the robot realize automatic welding. We're going to program the robot. What about the programming? Well, there are two ways. One is offline programming. Technology using virtual simulation. The robot on the computer. Operate on the computer. The other option is to try programming online. To use a robotic tester. Operate the robot on site to complete the programming. What we're using today is online trial programming. Use the operation button on the viewing angle device. Then operate the robot. Let him exercise according to our idea. Preserve during exercise. We need to save the coordinates of the point. So let me introduce you to our viewfinder. There are many function buttons on the viewing angle device. It needs to be done through these buttons above. And I'm going to walk you through them. What functions do our buttons have? The first is this big red button in the upper right corner. It's the emergency stop button. Students, throughout the internship, in case of an emergency, you can press the emergency stop button. When press it directly and it will go down. Lift the emergency stop. When rotate in the direction of this rotation, it lifts the report, lifts the emergency stop. The second one is to the left of the emergency stop button. It's a black key. It switches to manual and automatic mode. We can rotate it to the right. It will enter another interface. We can see that there is TET or Alt and X. What do you mean? The simple understanding is manual mode and automatic mode. T is called manual slow mode. T is called manual fast mode. Alt call internal automatic operation. External automatic operation. We really only need two models today. The first is called TE manual mode. The second is called Alt automatic mode. Let's see, I'm in TE mode right now. How to switch when switching to automatic mode? Click directly with your finger. If your finger can't click, okay. The reverse side of our viewfinder. There is a pen that can be pulled out in this position above. Everyone can use. After clicking Alt, we rotate the key back. After rotating back, in the status bar on the first line of our viewer, there is a place that shows a green Alt. This means it is now in automatic mode. What about when I switch to manual mode? Spin the key again. Click TE and rotate the key back. After rotating back, first line of status this place bar will display means it is manual mode. And the third one is the button that we use to make the robot move. There's our sensor 567 on the right hand side of the screen. 8 plus and minus signs. The first 6 are the buttons that move the robot. The last 2 are to control the robot manually and automatically. Percentage keystrokes. On the left, here's what we need to know. The second is the pause button of the program. During the program movement, you can press him to pause the operation. The fourth green triangle symbol key is the start button of the program. The start button is different when used in manual mode. We need to keep pressing it. Robots move. In automatic mode, we just need to click. The robot moves. The 4 buttons below. The first 2 are to control the extension of the welding wire, and the third one is the button we only need to actually solder at the end. Turn this on. In other cases, it is closed. In the middle, that's our home screen. The first line is called the status bar. Of some robots will be displayed, like manual mode, auto mode, and how fast it goes. It shows both. The second line is called the dialog box. Some long messages are displayed. The operating status of the robot. In the middle is our home screen area. The bottom line is the menu bar. There will be some menu commands, of course, except for the buttons on the front. It also has buttons on the reverse side. We can see there are also 2 white strips and a white dot. All 3 buttons are in manual mode. Power button, because it is not powered on by default in manual mode. To get the robot to move, we have to keep pressing it. Just press any of these 3 buttons. Usually we press this long white strip. Press it with 4 fingers. After pressing it, the robot will be powered. If you press it hard again, it will press again. Press it again and the power will be cut off. What about when we use it? You only need to press it once. How to judge whether the power on is successful? After pressing the power on button, front plus or minus sign on our right side, the corresponding XYZ will light up. The green one shows that the power is successful. So after understanding the test let's introduce it next. Motion coordinate system of robot. When the robot is in motion, they don't just exercise. They all move under the premise of a certain coordinate system. Our robot has a total of 4 coordinate systems. The first one is called axial coordinates. The second is called the world coordinate system. The third is called the base coordinate system. The fourth is called the instrumental coordinate system. Where do I switch? What about after we turn it on? The axis coordinate system will be displayed by default. There is a small robot icon above the AE. Click on it and it will show an axial coordinate system, global coordinate system, machine coordinate system, and tool coordinate system. The kind of coordinate system the robot company has use it directly after turning it on. The latter 2 coordinate systems can be customized according to the user. What about when we program today? You only need to use the first 2 coordinate systems. So let's first look at the axis. What about when we switch to axis coordinates? These though, plus and minus signs will correspond to A and A sign is the way though, respectively. What about when I press the button on the A axis? That's axis AE moving. What about when I press the button of the A axis? So the characteristics of the axial coordinate system are